Okay, this is the next one. We're going to do looking at some data sets and trying to get some information enough to get a linear function out of this. So 1.3, remember, it focuses mostly on just the concept of how to calculate or figure out slope and interpret it as a unit change or an average rate of change of whatever your function is measuring. 1.4 is actually putting it all together into a linear function or linear model that you can use to make estimates with. Okay, so what we have here is a table that's showing the average salary in dollars of a classroom teacher in the United States. It follows a linear pattern, and it's shown in the following table where X is the number of years from 1990. And then, of course, this would be your outputs, the salary. Okay, so they actually, a lot of times in a data set, they'll give you the year, but if you actually read the definition of the function, they do something called realigning your input or X values, realigning. So realigning your X values or your input values means typically it's something like this, where you have this start year, and rather than dealing with huge X values like 1,995 and trying to graph that stuff, we just scale it by the starting year. So they're saying our starting year is 1990. So basically you just subtract 1990 from every year, and what you have left is how many years after 1990 that year represents. So that just makes our numbers easier to work with. And then this is the output. So first thing we're going to do in this example, I know this is a group activity, so working it on your own is not the same, but what I typically have done in class is, hand this out from anywhere from 2 to 4 people, and you kind of, hang on, let me answer this text. No, I do not need any detergent. Okay. Sorry. So you'll often graph the data and see what kind of pattern it is. It tells us there's a linear pattern, so let's kind of see what happens. So if you're working in a group, obviously we're just going to do the part that says on your own, since unless you've already formed a study group, you don't really have anybody to discuss this stuff with, sadly. So, all right, so our first point, we're going to treat X as 0 and Y as 32,000, almost 33. So X is 0, there's 30, and there's 35, so 30, somewhere in there, and so on. 5 years is 37.8, so 5 years, that's 30, that's 35, that 37.8, probably something in there. 10 years is 42.7, so 40, there's 40, 42.7, probably right in there. 15, 47.6, so that's 45, so 47.6, probably right in the middle there. And then 2010, which would be 20 years later, would be 52.5. So 52.5, you're right about there. And just like they said, it does look pretty linear right there. You have pretty much a straight line up there. So let's go down here and do what it says to do. It says select 2 years and calculate the slope between the points. Okay, so it doesn't matter which pair that you pick. So I'm going to be really smart about this, and I'm going to pick. Now, each of these, you can think of this as an ordered pair where X is 0, comma, 32.94. So I'm going to pick, since I have to do a slope formula, I would like to subtract 0. So I'm going to use this as one of them. So I'm going to pick 32.904. I'm going to pick that one, and then I'll pick the one that goes by 10 because that should be easy to divide by. So 10 and 42.725. 42.725. Now, this actually is a perfect linear pattern, so it doesn't really matter which pair of points you pick, you're going to get the same slope. But let's work this out. We're going to do y2 minus y1, so 42,725 minus 32,904. It's going to give us 9,821 on top. So your slope will be 9,821 over x2 minus x1, which is dividing by 10, which will be 982.1. Okay, so it says, let's calculate the slope. So the slope is just this number, 982.1. And I just tried to pick numbers as I'm a lazy math person. Subtracting 0 is easy and dividing by 10 is easy, and so that's why I did it that way. If you had picked other values, you're also, when you did that final division, you're still going to get the same thing because these guys are all exactly on the same line. So it says express your integer or decimal rounded to the nearest tenth. Well, it works out to exactly the tenth. Okay, so 982.1 is our slope. Okay, so let's go in the next page. It says, I'm going to go down here to the, not the compare your answers, but what is the average annual? It should be the same. Everybody gets the same slope. All right, what is the average annual rate of change in teacher salaries? This is where you have the units to interpret that slope. Okay, so remember that the dollars were being registered for the outputs and the inputs were years. So it was a positive number. So the average annual rate of change would be $982.1. So I'm going to go ahead and make that look like cents per year. That would be the annual rate of change. That's the average rates per year. Write a sentence which interprets this change in salary in terms of years. Okay, so we would say the salary, you have to say what the function represents as outputs. You have to say whether it increases or decreases. So we're going to say it increases or increased, whatever, by, and then you actually state your slope amount, but you put the change units on it, dollars per year. That's a slope statement. You're saying you could just have one word or a phrase that represents the outputs. You have to say whether it's increasing or decreasing. You have to state by how much and what your input units are. Okay, so now what we're going to do, it says use one of your original points and your slope to write the equation of the linear function for salary. Okay, so remember a linear function looks like this, mx plus b, slope, you know that. Your y-intercept in a model like this, it's also your initial value. Okay, so now since they told us to measure the x values starting from 1990, this means what was the initial value in that year, 1990. So let's look at our chart and we can figure that out. So in 1990, right here, the starting salary was $32,904. So I don't have to do any of this 904. I don't really have to plug everything into the point slope formula. The slope, we just figured that out, was 982.1. So our salary means starting with a salary in 1990 of $32,904. The salaries increased every year on average by $982.1 per year. And again, if you want to, you can write that X term first, as I know we're used to writing it first. But when we're using modeling of actual situations, I think it's nice to start with the intercept. The y-intercept is your starting value, and then talk about how much it changes. So the plus means it's increasing. This is how much it increases per each year. Now it says, use the function to find the projected average salary for the year 2015. Okay, well, I've got to figure out what year for X that represents. So I've got to take 2015 minus 1990, that would be 25 years, wouldn't it? So it'd be 25 years. So what I'm going to do is just simply plug in 25 into this. I know there's other ways you can do it. I know you can kind of keep building on this idea, but I'm going to do that. It says use the function. So that's what I'm going to do. My function is, let's see here, 32, whoops, 32,904 plus, and we're talking about 25 years of this 982.1 increase. So there's my start by base salary in 1990. 25 years of this much annual increase gets the salary up to $57,456. So 57,456 and 50 cents. That's the salary. Okay, so it says compare your functions with the others in the group. You all use different points. It's going to be the same because these points are collinear. But this was just an idea about how to break down all those different parts of a linear function. So write the function notation statement to represent number 6. Okay, a function notation statement is where you have like a function of some number equals some other number. And this is your input, and this is your output. Okay, so our function's name, S of X, is our function. So right here, I'm going to put what was the input that I used. I put in 25 right here, so that was my function notation right there. So 25 was the input, and the output was that calculation that I got, 456.50. Okay, that's function notation. Now, a sentence to interpret a function statement is a little different from a sentence that just interprets slope. So when you're interpreting slope, you're just saying the output increases or decreases by a certain amount per year. But to make a function statement, you have to say what the 25 represents and what units it is and what this represents. So when the input's 25, the output's 57,000, but we're making it specific to this example. So we'll say, I'll just say this isn't the best way, but I should have just said in the year, what is it, 2015, or you could say 25 years after 1990. Then you just say what the other number represents. The salary is $57,456.50. Okay, so this is a function statement. You say what the input and the output represents and the units. So 25 years, we were stating the year, and $57,456 right there. Notice it's not dollars per year or anything, because that's not how much it's changing. It's the actual function's value. That is a salary value right there. Okay, so now if we went back through and graphed this on the original scatter plot, we don't have to do this for our first test, but we haven't put the data into our calculators yet. But if you went ahead and went back to our original statement, what is it? 32,904 plus 982.1x. So you've got 32,904 plus 982.1x. All right, well, our y-intercept would be this number, which is right there. If you go up 982.1, about 1,000 and over 1, it's going to line up exactly on those points like that. That would be easier to do on our calculator, but I don't want to right now take this one to show you how to put the points into your calculator yet. We'll do that when we get to regression. But yeah, that's one of the ways that we analyze data. We look at the points, we figure out a way to describe the line that connects to points, and then hopefully we graph that line and it lines up pretty much where those points are, which that's going to do. Okay, so that's how we break down the different parts of a linear function. The slope is how much it's changing. The intercept is sort of like your initial value at the beginning of all this, and then you can use it to calculate inputs and outputs however we like. So let me go ahead and stop this one now.